Hi guys, welcome to the new session. In today's session, we are going to speak about the intervals. Okay. Now, intervals, it is also the very important topic. Why? It is very basic thing, but it is very important because whenever we speak about the function, we have to define the domain, right? And in domain, we use the concept of intervals, right? So whenever like when you think of any interval in your mind that comes, you can say that the interval that comes to your mind, any interval, whether it is 2 5 or -1 to 4 or -2 to 2, right? All these intervals are the subset of real numbers, right? I hope you agree with me. Okay, so if you make it on the number line system, so you know on number line system, it contains all the real numbers. So these are just the small chunks, okay? So I can say that on number line system, minus infinity to infinity means real number. It is same like the universal set, and these are just the subsets of this universal set. Okay, so in this session we are going to talk about different type of intervals that do exist. Okay, so here we assume that we have two numbers, a and b, and these two numbers are the real numbers, and we define a is less than b. Okay, so what type of intervals can we get here? So we will start with the first one. The first one, it's going to be our open interval. Okay, open interval. Now, open interval means that it is defined by x such that here x lies between a and b. Okay, open interval means that my x can take all the values between a and b, but it will never take the value a and b. Okay, so a and b are not included. Okay, or the other way to say it is x belongs to a, b. These are open brackets. Open interval, it has open brackets. Sometimes we also represent these open brackets like this. Okay, but these are rarely used. Okay, so these type of brackets are rarely used. Most of the times, more often, you will see these brackets. Okay, so in open interval, what happen is that, let's say this is my number line, here minus infinity, here infinity. So here I have a, here I have b. Okay, so if x lies between a and b, what does it mean? If x lies between a and b, then here a and b are not included, which means that I cannot take the value of x as a or b. So a and b are not included. When they are not included, so here I have to represent it with hollow dot. Okay, and on the b I have to put the hollow dot too. Okay, so here this means x belongs to open interval AB. I hope you understand this. Okay, let's say here I have here says that your x lies between -3 to 5, right? So what does it mean? It means x belongs to -3 to 5, open bracket, means -3 and 5 are not included. So if I draw a number line, minus infinity to infinity, here 0, here 5 here, minus 3. Now minus 3 to 5 and open interval. So here I have to represent it with hollow dots, and then this represents minus 3, open interval, minus 3 to 5. I hope this is clear to you. Okay, now next, number 2, it is our closed interval. Okay, closed interval. Okay, it is defined as, okay, here your x will take all the values between a and b, including a and b. Okay, including a and b, and it is also represented as x belongs to, this is your closed bracket a b, closed bracket, closed interval, so we represent it with the closed brackets. Okay, so here, see here, if I have to represent it on number line, minus infinity to infinity, here a, here b. Now these closed intervals, they are represented, see here, if I have to represent this interval, closed interval, first what I will do, I will just find these 2 points here on the number line. Then I know that these 2 points are included because here I have a closed bracket. So inclusion, it is represented by solid dot. B is also included, solid dot. Now you can see here I have used hollow dot because here A and B both are excluded. So see here, hollow dots here, they are included. So here I have to use the solid dot. So this represents x belongs to closed interval AB. Okay, so let's do one example. We will take the same example here. You here x belongs to, x can take any value between minus 3 and 5, and it can take both the values minus 3 and 5, they are included. Okay, so let's see here, this is my number line, this is 0, this is 5, this is minus 3 here, so they are included, right? They are included. So here I will put solid dot, here solid dot 2, and this represents my open interval, sorry, my closed interval, minus 3 to 5. I hope this is clear to you. Now next is your open closed interval. Okay, open closed interval, it is defined as, okay, now see here, it is defined as open close. So it means x can take any value between a and b, and x cannot take a as a value, right? But it can take value b. Why? Because this side is open and this side is going to be closed. I hope you understand it. Okay, so it can also be represented as x belongs to a open and b closed, or it can also be represented as x belongs to a and b closed. Now this is also the bracket, this is also a bracket used as the replacement for this open bracket. This is also the open bracket. Okay, but we use it rarely. Okay, so let's see that we have a number line here, this is minus infinity, this is infinity, here I have a, here I have b. So if I have to represent open closed interval AB, then here, because this is open, so here I am going to use the hollow dot. This is closed, here solid dot. Okay, so this is going to represent here, this is going to represent x belongs to a, b. Understand? Let's take an example. Okay, so here your x lies between -3, this is open, and here this is closed. Okay, so here, see, this is number line, here 0, this is -3, this is 5. So this is open, right? Open means hollow and closed means solid. Okay, so this represents x belongs to open closed interval -3, 5. Understand? Then go to the next one, number 4. I hope this is visible, right? Yes. Next is your closed open. Okay, next is your closed open. Again, closed open, it's very easy. Closed open interval. Okay, so here it is defined as, okay, so here, because this is closed open, so here A, here B, this is closed means I have to include this. This is open, so I cannot include this, and the other way to represent it is as x belongs to A, and here open bracket B. Okay, so if I have to, or it can also be represented as x belongs to A and here B, this bracket, right? This bracket. So if I have to represent it on the number line, this is -infinity, infinity, this is A, this is B. So here A is included, right? So here I will just use the solid, right? And here B is not included. We have open bracket on B, so here hollow. So this represents closed open interval AB. Okay, now let's take same example here, x, and here this is closed open, means that here -3 we have to include, and we are not going to include 5. Okay, so here how it's going to look like, here 0, here 5, here -3. So here this is included, right? Why? Because it has a closed bracket. So here we are just going to use solid dot, and this is open, so here hollow dot. Okay, so this represents your closed open interval -3 to 5. Okay, now see here, there are different ways to write it, right? Okay, so the same thing, it can be written as, see here, what I can do here is, and this is x belongs to the open bracket, sorry, open interval -3 to 5. So here I can also say that, okay, here I can also say that x belongs to this is going to be real numbers, right? Set of real number minus and it's going to be real number minus this union this, right? Minus infinity to -2 -3 union 5 2, because here we have open bracket, so here I can say 2 5 to infinity. Sorry, is that correct? Real number minus this set -infinity to -3 union union 5 to infinity. Yes, this is correct. So this is also the another way to represent this, okay? Because if from the set of real number, if you are going to to take this element out, then you will be left with this, okay? So they are, see, once you get this interval, now there are different ways to represent this interval, okay? So the other way, what could be the other way, right? uh, the other way here, same, like r minus set of real number minus, uh, see here, it can be written as r minus, this is your closed, right? Closed, so I can say minus infinity to minus 3 open union, and here 5 to 5 to infinity. So it means this set. Understand? So uh, it's not difficult, okay? But here the main thing is that we have 4 different type of intervals: open, closed, and closed, open. Okay, now next thing here that I would like to discuss, it is the length of the interval. Okay, so what does that mean, length of the interval? Okay, just I need some space. Length of interval. Length of interval. Okay, length of interval. Now see here, uh, we have discussed 4 types of interval. This is open interval, this is closed interval, this is open closed, this is closed open. Okay, so no matter what type of interval you do have, length of interval is always going to be the same, and length of any of these interval is, it is defined as b minus a. Okay, let's say that you have to find out the length of this interval minus 3, open interval minus 3 to 5. So the length, it is going to be 5 minus of 3, which is 8. Okay, let's say that you have to find out the length of this interval, open interval 3 to 5. It's going to be 5 minus 3, which is equal to 2. Okay, so I hope this thing is clear to you. So length of interval, it is b minus a, and it is same for all the intervals. Okay, so it has nothing to do with your, if your interval is open or closed open or open closed. Okay, so take note of this point. Okay, then other thing that I would like to discuss here is, it is it is, this is my open interval AB, this is my closed interval AB. Okay, now see here, if I represent it on the on the number line system, this is minus infinity, this is infinity, this is A, this is B. Okay, so AB means any, this interval will take any value between A and B, but not A and B. Okay, and close interval AB, it will represents all the values between A and B, including A, B. Okay, including A, B. Okay, so it simply means that this interval, it is bigger. Okay, so I can say that, now see here, this interval is bigger and this interval is smaller. It contains all the values of this interval, right? And it also contains value A and B, because A and B are included. So here I can say that this open interval AB, it is subset of your main closed interval AB. Okay, so this is very important result. Okay, this is very, very important result. Okay, now here also one thing that uh, I want to discuss here is that let's say that that here I have a number line and here I have interval. Okay, so x represents the set of elements that belongs to this interval minus 3 to 5. Okay, minus 3 to 5. Okay, now see here, so on this number line here I have 0, here I have 5, and here I have minus 3. Now minus 3 to 5 open intervals, it means hollow, right? Hollow. Now this means my open interval minus 3 to 5, and it contains all the value between minus 3 and 5. Now here I am more interested in finding the complement of this x. So here, now see here, x complement, it means that it contains all the values on this number line except the values in this interval, right? So what does it mean? It means that r minus, right, r minus all the values that lies in this interval minus 3 to 5. Okay, so what's going to be that? So it's going to be minus infinity to minus 3, right? Minus infinity to minus 3, here closed bracket. Why? Because here I have open, and union 5 to infinity, right? 5 to infinity. Okay, so that what x complement means here. So I hope this point is clear to you. Okay, so that's all for today, and I will see you in the next video. Thank you very much. Bye bye.